Okay, what we're going to get ready to do today is focus on the integration of exponentials, but we're going to do a few reminders first. So the first reminder I want to give you is the definition of a logarithmic function to base a. So if a is any number not equal to 1, we can redefine the logarithmic function in terms of a natural log by writing the ln of x over the ln of a, or you can break it up in this fashion. I just typically like to do ln of x over ln of a. So anytime we want to express a log in terms of natural log, we can change it into that form. The derivatives, again, that we've already discussed, the derivative of a to the u, and I'll just go ahead and do this one because it's the more complex of it. If you have something other than an x, you write down the ln of that base a to the u, and then you take the derivative of that exponent for your final derivative. The ln, or the derivatives of logs, is 1 over the ln of that a, that base a, with the u, and then you take the derivative of that u. Those are just reviews. What we're going to do is go ahead and do a logarithmic differentiation problem. So on this problem, I'm going to use logarithmic differentiation to find dy over dx because it's going to make it easier than using an exponential form. So we're just going to take the natural log of each side, and then when we do that, we're able to use the rules of logs and bring out my exponent. So I have x minus 1 times ln x now. Now that I've rewritten it, I'm going to go ahead and find the derivative with respect to x. So the derivative would be 1 over y dy over dx, because it's not an x, I have to remember to write the dy over dx, equals, I have a product rule here. So I've got first times the derivative of the second plus the second times the derivative of the first, which would be a 1. We have to get dy over dx by itself, so I'm going to do that by multiplying by y on both sides. So I'll put y times this whole amount. Let's go ahead and rewrite this as x minus 1 over x plus, I just have ln of x. My last step is to substitute my y and put it in terms of x's. So y is equal to x to the x minus 1. And then I have x times x minus 1 over x plus ln of x. Next problems, we want to start talking about integrals. So the integrals of an exponential is you write 1 over the ln of the base times the exponential plus c. We will be making use statements anytime we have something other than just the plain old x as the exponent. So in this first problem, I can see how I'm going to need to make a u statement because I don't have a plain old x. So I'm going to write over here to the side that u is equal to negative x, and I'll take the derivative of that, which is negative 1 dx. Now I'm going to rewrite this in terms of u because I know the integral of any number to a u, but that takes care of this portion, so I still need to take care of the dx, and I'll take care of the dx by multiplying or dividing by negative 1 on both sides, which gives me a negative du. So I'll write a negative du, and then I'm going to integrate this. Well, let's go back to the integrals. So I'm supposed to write 1 over the ln of the base times the exponential. So negative 1 over the ln of my base, and I only brought just down this negative. You don't typically have a negative in front, but it's 1 over ln of the a times 5 to the u, and then we just write plus c. Last step is just to substitute our x values back in. So I get negative 1 over ln 5 times 5 to the negative x plus c. Alright, we're going to continue to find some integrals. So working with this next problem, we're going to have to make another u statement. So we're going to make our u be the exponent. There's our typical hint. Since we have a constant base and some other exponent, we're going to go ahead and make our u be 3 minus x squared. So when I take the derivative of this, I get 2 rewrite the inside and lower it by 1. But again, remember, take the derivative of that inside part, so that's a negative 1 dx. So I've got du is equal to negative 2, 3 minus x dx. Alright, so when we go ahead and start to rewrite this, I'll have 7 to the u. That takes care of this portion. I just need a 3 minus x dx. I have that right here, as long as I move my negative 2 to the other side. So I end up getting negative 1/2 du. So I've got negative 1/2. The integral of an exponential is 1 over the ln of the base times the exponential plus c. So what I'll do is I'll rewrite this first part together times 7 to the u being 3 minus x squared plus c. In my next problem, I have another exponential, and I'll go ahead and work with that. I'll make my u equal to sine x. The derivative of sine x is cosine x dx, so I get rid of everything else I needed. So I have 2 to the u, and I need a cosine x dx, and I have exactly that, so I can put du. The integral of the exponential would be 1 over ln of 2 to the u plus c. So I get 1 over ln of 2 times 2 to the sine x plus c. We could just put parentheses there as well. Looking at another one. This time I have an e. So we're going to solve this differential equation. Remember, that just means get dy by itself first of all. And then we can integrate both sides. That will give me my original function. And we're supposed to find the particular solution given this point. Now, the sketching of the two approximate solutions is from the slope fields, and so you just follow the curves. And then the one particular solution would be the curve that goes through this particular point. We can talk about that in class if you would like. So the integration or integral of dy is y equals, and now I have the integral here. Well, I can't integrate this. I know the integral of e to the u. So I'm going to go over here and make a u statement. Take the derivative. And then rewrite this. So I got the integral of e to the u. I need exactly cosine x dx. I have exactly that with the du. So now I have y equals e to the u plus c. So I have y equals e to the sine x plus c. Now for this particular solution, I would plug in 2 for y and pi for the sine. The sine of pi is 0, so e to the 0 plus c. Well, I know that e to the 0 is 1, so my c value ends up being 1. So the solution to this answer, or to this differential equation, is e to the sine x plus 1. Alright, the last thing we're going to do with exponential functions is talk about compound interest formulas. Compound interest formulas are used to figure out interest on loans and bank interest and annual interest of anything. So there's different types of compound interest formulas. We've got compound n times per year, meaning they might compound your interest monthly, and they might compound it annually, or maybe they just do it twice a year. However many times a year, n stands for that. And then compounding continuously means just all the time. It's compounded continuously, minute by minute. So it's used is an E. So you can see the difference between the two. What we're going to do is we're going to use both of those, and we're going to fill out a couple charts. Now, I will show you how to do a little bit of this with the calculator, but overall, I'll let you guys see if you can come up with numbers using your calculators after we go through a couple of these. I'll write in the answers, and then you guys could check them on your own. And if you have any problems, you'll need to ask me during class to make sure that you're okay. So what we're going to do is we're going to use the two formulas. A equals P times 1 plus R over N to the NT. The other one, and that's only for this part, is A equals P E to the RT. Now, how do we do this? Well, the P is the principal amount. So, in this problem, we're talking about investing $5,000, and we're talking about doing that at a rate of 7%. The number of times it's being compounded for this particular column is 1 time, and then we'll have 1 times the number of years, 25. So when we use our calculator, we need to make sure we do order of operations. So we'll have our 1.07, so let me clear that out. We'll write this down. 5,000 times 1.07 to the 25th power. So I'm going to go 1.07 to the 25th. And I'll hit enter. And then what I want to do is I want to take that times the principal rate, which was 500. And it didn't accept it. So let me put that back in. I'll put it all in one. I'm never good with this calculator. So 1.07 to the 25th power, and we're multiplying that times our investment of $5,000. I get $27,137. So I'll come back here and I'll write that on my screen. Now, all you would do is change, and I'll go ahead and bring out my eraser to do that. We would just change this to be a 2 for being compounded twice per year. So this would be a 2, and then this would be a 2. Everything else would remain the same. Finishing off this table, the answers would be $27,924.63, $28,340.78, $28,627.09, $28,768.19. Compounded continuously, the way you'd put this in is 5,000 for your principal, e to the 0.07 times 25. So you need to use your E button on your calculator. So you'd hit 5,000 times E to the parenthesis 0.07 times 25. Enter. And we have our answer right there, and I'll copy that over. It's 28,773.01.